Hello, friends. Today we are going to talk about soil classification and various problems related to soil classification we will be taking up. So, we'll begin with a gate problem of 2009. This is a simple problem on soil classification. So, dealing with classifications of soil. You have learned about the soil classification and Indian standard system of soil classifications. You have learned it, and normally the questions are based on that. So one of the question is the lab test results of a soil sample are given as the percentage finer than 4.75 mm equal to 60 percentage finer than 75 micron is given as 30 and liquid limit has been found out to be 35% and the plastic limit has been found as 27%. Classify the soil. Based on above result. So you will have to classify it. So we can see the solution of this problem. Now, if you see the percentage finer than 4.75 mm is all fine aggregates, that is sandy particles, and also the fine particles. So that's given to you as 60%, and percentage finer than 75 micron is all fines. So fine, that is fine grained soil. Fine grained soils are silt and clay, you know it, and the passing through 75 micron equal to 30%. That is, it is more than 12%. So you should carry out the liquid limit, plastic limit, etc. All the tests you should carry it out. So here liquid limit is given, plastic limit is given to you. So how will you classify this particular soil? Look here, we can find out based on this liquid limit and plastic limit, we can find out the plasticity index. So plasticity index IP is difference of liquid limit minus plastic limit. That means it is going to be 35 minus 27. So it is 8%. So IP is known to you as 8%. Now, this could be because passing 75 micron, it could be silt, it is fine grained, it could be clay. So whether it is clay or silt, that you can find it out based on liquid limit and based on plasticity index. So Indian Standard Soil Classification System, there you have the plasticity chart. In the plasticity chart, you know that here it is the liquid limit on the x-axis, and on the y-axis it is plasticity index in percent. And liquid limit at 20%, and let's say liquid limit at 100%, IP here is 60. So from 0, 0, 0, it goes plasticity index, and there is a line known as A line. And at 35% and less than that, the soil is going to be CL. Between 35 and 50, it is going to be CI above the A line, and beyond 50%, it is going to be CH. And below the A line, it is going to be silt. So it is all silt here, or it could be organic soil. And between 4 and 7, IP, it is a dual combination. It is known as CL-ML, where CA stands for clay, M stands for silt, L stands for low plasticity, I intermediate plasticity, H high plasticity. For example, the soil which contains a mineral like montmorillonite is considered to be highly plastic. Black cotton soil, CH is always very high. This liquid limit is going to be high, and plasticity index is also going to be high on the lower side. So here you can just find out the classification based on this. So here you have got a line. The equation of the A line is IP of A line is given as 0.73 liquid limit minus 20. This is the equation of this A line. So now your liquid limit is known to you. So what is the IP of the A line? IP of the A line is 0.73. Liquid limit is 35 and minus 20. So if you calculate this, and I will take the calculator and calculate it. Just a minute. So if you calculate it, this is going to be 15 into 0.73. This gives you 10.95. So IP of a line, if you calculate it, it is going to be this much. And here, the IP of the soil mass based on the test is 35 minus 27, that is only 8%. So the point is below the A line. Therefore, IP of soil is below A line, and therefore it is going to be silt, you know it. So from this liquid limit and plastic limit, now it is only 30%, and the percentage of uh, coarse grained soil is going to be substantial here. Remaining is going to be coarse grained soil, and therefore here the percentage of sand is going to be quite considerable, 60%. Therefore the classification for silt is M, and classification for this 60% finer than 4.75 mm. So it is going to be sand. So sand and the finers are going to be silt. So classification will be SM. So it is going to be silty sand. So the classification therefore is silty sand. So the answer is SM. This is the answer. This is the second question related to the behavior of black cotton soil. The black cotton soil, and you have to find out the clay mineral due to which it has got swelling behavior. So the swelling characteristic, which clay mineral is responsible? So the answer of this, you know it, that black cotton soil is highly expansive, having swelling behavior due to a mineral, clay mineral, known as Mount Morillonite. So this clay mineral is responsible for the swelling behavior. The next question is 2016. Set 1. A fine grained soil is found to be plastic in the water content range of 26 to 48%. That's 48%. As per IS classification system, classification system, the soil is classified as per IS soil classification, give the classification of soil. So the solution for finding out the classification has to be based on the water content range, which is given to you. It is plastic. So you know that how the soil, when the water content is going to change, it is going to be beyond this. It is in liquid condition, and this is called the liquid limit. Beyond this, it remains in plastic condition, and this is called WP. So it is in this range, plastic range. It is given as that it is in to be plastic in the water content range of 26 to 48%. So WL is given to you as 48% and WP is given as 26%. And this is called the shrinkage limit. So plastic shrinkage limit, plastic limit, liquid limit. So here in this problem, the liquid limit is 48%. Plastic limit is 26%. Therefore, IP, that is the plasticity index, will be liquid limit minus plastic limit. So 48 minus 26. So this becomes 22%. So IP of the soil, fine grained soil, is 22%. Now, from soil classification system, we have IP and liquid limit, A line. The equation of the A line is known to you. So for liquid limit of 48%, the equation of A line, IP of A line, can be calculated from the formula 0.73 LL minus 20. So this can be calculated. LL is already known. So this becomes 48 minus 20, 28 into 0.73. So if you calculate 0.73 into 28, this is 20.44. So IP of A line, when liquid limit is 48, this value is 20.44. But your IP is 22. That means the point is above the A line. So this soil, the IP is greater. So IP of soil is greater than IP of A line. That means the point is above the A line. And you know that the range 35% liquid limit and 50% liquid limit, it is going to be CI between 35 and 50. And your liquid limit is 48. Therefore, the soil is classified as CI. So This is the answer. This is the soil classification. So you can see the answer of this question. And many such problems have been repeated year after year in GATE examination. So this IS soil classification, this plasticity chart is very, very important. You should refer that. Now 2021 set 2. This is again interesting question that full form of soil symbol MH. You know, M is used for silt and H for high plasticity. Therefore, MH is silt or high plastic silt, or silt with high plasticity. So, a simple question that is asked in 2021. There was another question in 2021 set 2 itself. This question is pertaining to laboratory test. So, lab test has been carried out on the soil sample, and the liquid limit is given over here as 60%. So this is another problem. So liquid limit is given to you, and the plastic limit is also given. As 27%, and the natural water content is given as 32%. And the flow index has been found out from flow line as 27. So from the lab test, the informations are given to you. Based on this information, you have to find toughness index of the soil, that is IT, and also liquidity index. And so we have to find out toughness index and liquidity index. Now we know that toughness index solution, you can just see IT, you know that is, it is the plasticity index divided by flow index. It is the ratio of plasticity index upon flow index. Now the plasticity index can be easily found out because you have liquid limit and plastic limit. Therefore, the difference of the two can give you the plasticity index. So 60 minus 27 will give you the plasticity index, and the flow index is given to you as 27. So you are going to calculate this. You can greater than 1. If it is less than 1, then naturally you are going to have a friable type of soil. So the plasticity index and the flow index, uh, toughness index is going to be greater than 1. So toughness index, then next is liquidity index. So liquidity index is the natural moisture content that is given in the problem as 32% and minus the plastic limit of the soil divided by IP, plasticity index. This is the formula for liquidity index. So natural moisture content 32 and plasticity index 27 and the IP value is going to be 60 minus 27, that is 33. So here in this problem, we know natural moisture content, we know the plasticity, uh, mm, we know the plastic limit, and we also know the denominator plasticity index. Therefore, the simple calculation, we have to substitute natural moisture content, we have to substitute the value of plastic limit and plasticity index. So, whatever is the given data that suggests that it is 5 divided by, this is going to be 33. So liquidity index also you can find it out. So you can get the idea very easily what is the condition of the soil depending upon the natural moisture content. The natural moisture content is greater than plastic limit but less than liquid limit. So liquidity index, if natural moisture content is going to be very near to liquid limit, then the value of liquidity index will be higher, and that shows the condition that it is very near to the liquid limit. So this was 2021. The next problem is 2022 set 1. And this is place them. So the following soils are given. The CHML, then SP and SW. CH means it is going to be clay with high plasticity, silt with low plasticity, sand poorly graded, sand well graded. So 4 types of soils are given and you are asked to place them in decreasing order. Place them in decreasing order of their hydraulic conductivity. So the sand will have higher value and a lower value will be for clay. So here the if you want to put them in decreasing order, the hydraulic conductivity for well graded sand is the highest, followed by poorly graded sand, followed by ML, and the last one will be CH. So uh, you have the soil given. So well graded sand, poorly graded sand, silt with low plasticity, and clay with high plasticity has the least value of hydraulic conductivity. It doesn't permit, the permeability is so low and doesn't permit the flow of water through it. So the answer is going to be like this. Then in 2021, another problem is like this. So it's a very simple chapter. We have to find out the correct match correct match between physical states of soil and governing condition. Governing condition. So the group A1 deals with the physical state of the soil, that is, it is normally consolidated soil. Number 2 is going to be quick clay. Number 3 is sand in critical state. And number 4 is clay of high plasticity. And here the governing condition is given in group 2. P denotes sensitivity greater than 16. Q denotes dilation angle equal to 0, and R denotes the governing condition, liquid limit greater than 50, and S OCR over consolidated ratio equal to 1. So yeah, now you can analyze and find out the solution. You will have to go for correct match between the physical states, the governing condition. So find out the solution. If it is normally consolidated soil, the over consolidation ratio becomes 1. So 1 is matching with this. Now another is quick clay. Quick clay, you can see for quick clay this it is highly sensitive. So sensitivity is greater than 16. So it is combining with P. Sand in critical state, the dilation angle will be always 0 because it is in, given that it is in critical state. So in critical state, no dilation angle will be 0. So the third one matches with Q, dilation angle. And the fourth one, clay of high plasticity, is you know it that when as per plasticity chart, clay with high plasticity we call it CH, and for classifying CH the liquid limit should be greater than 50. Naturally the here it is going to combine fourth one with this one. So Q with R. So this is the answer. Correct match. This is the correct match. The another problem on CV analysis was asked in 2011. That also other problems are of similar nature. So mainly it is on plasticity chart, IS soil classification system. So Indian standard soil classification is known to all of you. I have dealt over here also. And if you see the 2011 question, this is related to sieve analysis. So the sieve analysis is carried out for 3 different types of sand. So sieve analysis was carried out for 3 different types of sand and labeled as P, Q, R sand. So these were the 3 types and their fineness modulus were calculated. Fineness modulus FM are calculated and the gradation curve, from the gradation curve curves given in figure here. I'll draw the figure also. The gradation curves find the relation among, find the relationship amongst their FM, fineness modulus. So this is the question, and the figure is given here. The figure is percentage finer, and here it is the sieve size, and the curves are also given to you. The another curve, this is for P sand, this is for Q, and this is for R sand. This is the gradation curve. From this gradation curve, the relationship, if you want to find out between amongst their fineness modulus, the fineness modulus of this with the solid line, that is of Q sand, can be find out as it is in between P and R. It will be the geometric mean. We know it. And it is very simple. The fineness modulus of Q sand, FMQ, equal to the fineness modulus of Pn multiplied by fineness modulus of R. So the relationship amongst their fineness modulus can be written and it can be solved. Friends, the most important is here the soil classification based on IS soil classification system, which you have learned it, and problem year after year such problems are repeated. So thank you very much. We have covered this particular chapter. In the next video, we will try to cover up consolidation and effective stress principle, and then we will go for further practice. So practice some of the new questions I will be solving, explaining conceptually, so that you learn it in a better way. Thank you very much.